Welcome to the Walton Pie. Today we are going to talk about partitions and transversals. As a quick review, in our last video we talked about equivalence classes. So remember that an equivalence class is going to be the set of elements that relate to some element A under a given equivalence relation. Now, these equivalence classes have specific properties. Specifically, all three of these things that are written are equivalent. If x relates to y, then the class of x is the same as the class of y, which also means that the class of x intersected with the class of y is not equal to the empty set. So, either all three of these are true, or none of them are true. There is no way to have anything other than that. So a partition is going to be a collection of subsets of A that satisfies three specific properties. There is no empty set. Every element in A is an element of some set in P, and any two sets in P are disjoint, meaning that if you take two sets and look at their intersection, it either will say that the two sets are equal, or the two sets have no elements in common. So an example of a partition on the set A, which is this set containing A, B, C, D, E, F, G, and H, one partition could be the set containing A and C, the set containing B, F, G, the set containing D, and then the set containing E, H. This is a partition because every element is in one of the sets, no element is in more than one set, and none of the sets are empty. One way to visualize the partition is by writing all of the elements of A in one box and then drawing little circles or rectangles or some way of dividing up the box so that every element is in a different box and there aren't any empty boxes. So for this partition P, this box is one demonstration of how we can visualize that partition. We also can see that a partition is going to correspond to a specific set of equivalence classes. So here we have the class of A is the same as the class of C because those two are in the same set in the partition. Similarly, the class of B is equal to the class of G, which is equal to the class of F, because all of those are in the same set in P as well. This is actually going to be one of the theorems that we can have. If we have an equivalence relation on a set A, and where we set bracket A to denote the equivalence class of A, then the set P of all equivalence classes is going to be a partition on A. In order to show that this forms a partition, we need to show that P is going to satisfy the three properties of a partition. Namely, that no set is empty, every element of A is in some set of P, and any two sets in P are disjoint. Let's start by proving that no set in P is empty. We know that every set in P is the equivalence class of some element in the set A, so that means that every set in P has to have at least that element in it. So no set is going to be empty. In order to show that every element in A is in one of the sets, we can start by noticing that the element A is in the equivalence class of A, and so because P is the set of all equivalence classes, we can just take the set of every equivalence class one at a time, so that means that A is going to be in at least its own equivalence class. We can then show that any two sets in P are disjoint. If we start with the assumption that two sets X and Y are both in P, and the element A is in both of them, since they are equivalence classes, and we know that the intersection is non-empty, we know that either the two classes are disjoint or they are identical. Since the intersection is non-empty, we know that they must be identical, so that tells us that X equals Y. Therefore, if A is in two different equivalence classes, those two classes were really the same. The next thing we have is what's called a transversal. So once we have a partition, a transversal is a set where we take exactly one element from every single set in the partition. Or, in terms of equivalence classes, A transversal is a set which contains exactly one element from every equivalence class. So, going back to our same example, the large letters in red is one example of a transversal. The set CDFH is a set that contains one element from every equivalence class from this partition. I hope this video was helpful in order to understand transversals and partitions. If it was, feel free to leave a like and subscribe. It helps me out quite a bit. Have a great day and good luck with all of your math.